In this video, we are going to discuss the addressing modes of Intel 8085. Now, addressing mode means how a data is referred by an instruction, and depending upon that, we have 5 types of addressing modes. These are the 5 addressing modes of 8085: immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and the last one is implicit addressing mode. Now let's discuss them one by one. First one is immediate addressing mode. When the data is mentioned inside the instruction itself, it's called immediate addressing mode. Some examples of immediate addressing modes are, these are the few examples of immediate addressing mode. You can clearly see an I at the end of each of the instruction, which means it is immediate addressing mode. That means the data is given inside the instruction itself. The first instruction, MVI A,59H, it loads the accumulator with 59H, which is already mentioned in the instruction. Similarly, the second instruction, LXI H,2151H, it loads the HL pair with this 16-bit data. 21 will be stored in H and 51 will be stored in L register. Similarly, the third instruction also is an example of immediate addressing mode. This instruction means that the content of the accumulator, whatever is this, will be added with 51, which is an immediate data, and the result will be stored in the accumulator. So these are few examples of immediate addressing mode where data is mentioned within the instruction. The next addressing mode is register addressing mode. In this type of addressing mode, the name of the register is only mentioned in the instruction. Few examples of register addressing modes are, these are few examples of register addressing mode. As it can be seen from the 3 examples, the names of the registers are mentioned. The first instruction, move A, B, means the content of register B will be transferred to register A. The second instruction means the content of register A will be added with the content of register B, and the result will be stored in register A. The third instruction, INX H, means the content of HL pair will be incremented by 1. In all these instructions, the name of the register is mentioned where the data is residing. The third addressing mode is direct addressing mode. In this addressing mode, the address of the data is given in the instruction. Some examples of direct addressing mode are, these are 2 examples of direct addressing mode where the address of the data is mentioned inside the instruction. The first instruction, STA 5000H, means that the content of the accumulator will be transferred to a memory location whose address is 5000. Similarly, LDA 8000 means the content of memory location 8000 will be transferred to the accumulator. In both the cases, the address of the data is mentioned. The fourth addressing mode is the register indirect addressing mode. In this type of addressing mode, the register that are mentioned in the instruction work as a memory pointer. So whatever register is being used or register pair is being used, they are used as a memory pointer. Few examples of register indirect addressing mode are, these are the few examples of register indirect addressing mode. The first example, move A, M. In this instruction, the content of HL pair is treated as a memory pointer. We have seen earlier that whatever we have after the comma is always the source, and before the comma is the destination. Here something will be transferred to the accumulator. So accumulator is the destination here. The source is pointed out by the HL pair. Whatever is inside the HL pair is data. But whenever these type of instructions are executed, the content of HL pair is treated as an address. So whatever the content of the HL pair is, let's assume that the content of the HL pair is 5030. H has 50 and L has 30. When this instruction is executed, the content of 5030 from the memory location 5030 will be transferred to the accumulator. Similarly, the second instruction, add M, the content of the accumulator will be added with something. Now that will be coming from a location from memory whose address is given by the HL pair. So HL pair will have some data. The data is 8000. Now this 8000 will be treated as an address, and from that 8000 address from the memory, the data will be transferred to the processor and then it will be added to the content of the accumulator. Now in the first two examples, HL pair was used as a memory pointer. In the third example, register pair BC is being used as a memory pointer. STAX B means the content of the accumulator will be transferred into some memory location. The address of the memory location is now given by the BC register pair. Let's assume that BC register pair has 9000 in them. So when STAX B instruction is executed, the content of the accumulator will be transferred to a memory location 9000, which is pointed by BC register pair. The last addressing mode we are going to discuss is the implicit addressing mode. In this type of instruction, the instruction itself specifies the data to be operated. So the examples of this are, these are the two examples of implicit addressing mode. The first one is CMA. Here A means the accumulator. The content of the accumulator will be complemented. Now in this instruction, the data is not given directly, the register name is not mentioned separately, the address of the data is not given, nor any register pointer is being used here. Inside the instruction itself, the name of the register is given. CMA means complement the content of the accumulator. Similarly, next instruction STC deals with the carry flag. STC means set the carry. Whenever this instruction is executed, the carry flag is set to 1. So in the instruction itself, the data is mentioned. Before I conclude, I would like to mention that we have discussed 5 types of addressing modes. It doesn't mean that all the instructions should have some kind of addressing mode. The instruction which deals with data, they will only have addressing modes. Instructions like halt, no operation, these instructions do not have any data related to them. That's why they do not fall under any kind of addressing mode. So here we end our discussion for the addressing modes of 8085.